All you need to be able to do is identify, Jason, we'll get to that in a bit, okay? All you need to be able to do is identify the fundamental force. Danielle, are we doing that test? Thank you for your patience. So, the number one fundamental force is gravity. Gravity is an attractive force. Doesn't get me down. Like that? Oops. Gravity is an attractive force that exists between all objects. Colin, can I use you as a demonstration? Colin is attracted to his binder. No, you are. Gravitational, speaking, of course, right? And his binder is attracted to him. For me? Moon and Earth? Oh, you don't want. Oh. I'm attracted to this calculator. I am, gravitationally speaking. The calculator is attracted to me. Oh, there's a lot of good gags here, aren't there? Gravity is an attractive force that exists literally between all objects. The gravitational force between the center of the Earth and objects near it causes objects to fall toward the surface of the Earth, right? So if I go and I get my tennis balls out, I'm done. That's why, yeah, that's why you are attracted to the Earth. And the Earth is attracted to you. We watched the video, did we not, about if everyone jumped at the same time?
No. Yeah.
But yeah, so, right?
Nothing.
Really? No. Okay. So literally, right now the ball is attracted to the Earth. I'm exerting a force not allowing it to happen. And when I drop it, of course, the ball is a pretty good demonstration, right? The ball is attracted to the Earth. And as it's falling, here's the learning part, you guys. You gotta listen. As I drop it, does the Earth move up towards the ball?
No.
It does, actually. I mean, it's,
Very slight.
more than very slight.
Is that why the world spins faster if we all lay down?
Yeah, part of it. Well, that's got to do with the center. Yeah, exactly. Yeah.
So,
Energy is equal to mass times the speed of light squared, and Logan needs to put her phone away so she can listen and focus on what we're talking about up here. You're gonna be.
I think that's a threat.
You're absolutely right. I'm threatening to take away her phone unless she puts it away and listens. Well within my rights. Remember, we're here to learn and get good marks. You guys want to know, what can we do to get good marks? Put away your phones. Listen. Okay, now, this is an attractive force towards the Earth. Now, I guess I could say a little bit more about this here, but I think as I'm kind of killing time right now, thinking about what's coming up, I think I talk more about that when I deal with gravitational fields. So I'm just going to leave it at that, right? There's the attractive force. The second one is an electromagnetic force. The electromagnetic force holds matter together by providing the force that binds atoms into molecules. I really, really, really want excellent. That's what I want. The electromagnetic force holds matter together by providing the force that binds atoms into molecules. It is literally what's holding you together. Your body is made up of a lot of carbon, some water, a lot of other things, right? But it's literally what's holding you together. Providing the force that binds atoms into molecules. H2O is a molecule, right? Hydrogen and oxygen, right? So it's the force that holds the hydrogen and the oxygen together to form what? The electromagnetic force. Now, I guess I should have prefaced all this. I got a little distracted there, but I have to go down a library. When we talk about fundamental forces, what does the word fundamental mean? What does it mean? It never means fun when you say fun. At the start of a science unit, fundamental never, ever, ever means fun. Basic. The most basic building blocks that there are. Right? Are there other forces that exist? Absolutely, and they are a combination of or produced by these fundamental forces. The fundamental forces have nothing, we can't really, I'm gonna put this. We can explain them to some degree, right? But there is no other sort of next step sort of beyond them, behind them. They are the basic building blocks. Electromagnetic force is the second one. Now, you know this already. The force between particles of opposite charge is attractive, right? Positive attract negative. You guys know that. You were probably taught that about grade 5 or so. I don't know. I really don't know. Right? Positive charges attract negative charges. And conversely, the force between particles of the same charge is repulsive. Ooh. Positive don't like other positives, and negatives don't like other negatives. Do you need to draw those pictures? Entirely up to you. You probably all already know this, right? I'm going to run and do a test while you guys are doing that. Alrighty, so we got two fundamental forces. We got gravity, which pulls things down, and we got electromagnetic force that holds things together, right? When I drop the ball, is gravity happening? Yes. Is the electromagnetic force happening? Yes. Like, actually, it's happening right now because gravity's trying to pull the ball down, but the electromagnetic force is actually holding the ball together. Which one is stronger? Think about that. Just think. Okay, so since like charges repel one another, positives don't like each other, negatives don't like each other. How can positively charged protons, like if we look at the periodic table, let's just pick something at random here. Let's say carbon is number 6, has 6 protons. 6 protons tightly packed in the nucleus. I thought positives didn't want to be near each other. How can positively charged protons exist closely packed in an atomic nucleus? Positive things don't like other positive things. There is a third fundamental force known as the strong nuclear force. The strong nuclear force. What does it do? Well, it exists only in the nucleus. It holds protons and neutrons together in atomic nuclei. It is the strongest force. But it acts over only very short distances inside a nucleus. And that distance inside a nucleus is practically unfathomable. We cannot really understand how close they are together. And do you need that picture? Entirely up to you. I'll tell you exactly what I expect you to know at the end. Pardon me? The last of the fundamental forces is the weak nuclear force. This is responsible for some kinds of radioactive decay, such as the decay that creates radon gas.
Did you just hear this color?
No, I didn't hear that. Oh yeah, big dome. Do you guys know what radon gas is? Radon gas is present in just about everyone's home. It comes through your basement floor. There are ways you can reduce it. It's the second most common cause of lung cancer in Canada, and it's especially prevalent in Manitoba, and even more so in the Parkland region. There's a good chance that you have high levels of radon gas in your basement. I do. There are things you can do to sort of solve it, kind of thing. But it's basically radiation. It's a gas that's caused by radiation, and it's coming through the cracks in your basement floor. And it causes lung cancer. It's even worse if you happen to be a smoker. There's your fun fact of the day, eh?
Thanks.
Yeah. You'll all sleep easy tonight, won't you? It is the next to weakest force that acts only when particles are close together. The weak nuclear force. It's not the weakest, it's the second weakest. So what we're actually going to do is, we're not going to blow anything up. Maybe a balloon. A little bit of logic here. This is one thing I sort of throw at this. We've got our 4 fundamental forces. I've told you what's the strongest one, and I've told you which one is the second weakest. So let's arrange them in order of strongest to weakest. Strongest, weakest. Which one was the strongest? The strong nuclear force. And the weakest, next to weakest, the second weakest is the weak nuclear force. So the last two are electromagnetic and gravitational. Which one is weaker, do you think? Gravitational or electromagnetic? Why do you say that? Yeah, exactly. In fact, I sort of alluded to it already, right? If you were paying attention, you would have got that, right? I said that the gravity's pulling the bottom part of the ball down, but the ball doesn't sort of like rip apart on you, right? So it's that electromagnetic force that holds the ball together, holds you together. Okay, so what do you need to know from all this? You need to know the names of the 4, have kind of a vague understanding of what they do, and you should have a pretty good understanding of the relative strengths. That's about all I'm going to say. Okay? I'm not going to expect you to write out all this stuff. You should simply know their names, the order of strength, and have a sort of a basic understanding of what each one does. Surely, to goodness, if I say explain what the gravitational force does, you can explain. Okay? There. You can check off outcome number 1. Right? Wouldn't it be nice if all the outcomes were sort of equally weighted, but they're not, right? So that was pretty easy. The last one, solving problems, will be considerably more. Okay, so for a variety of reasons, one being that I'm getting behind in my afternoon class, I'm going to give you guys the rest of this period because